Maclaurin series for arc sine, you say, so that we can estimate pi? Sounds good. Here's our formula for the Maclaurin series, and also here is the derivative in the formula book for arc sine. We don't need to prove that from first principles, although make sure you can. We're asked to determine the first two non-zero terms in ascending powers of x of this Maclaurin series. So I'm not just going to work out loads of derivatives. I'm going to work out a derivative, then find out what it is evaluated when x is 0 in each case. So when f of x is arc sine, f of 0 is actually 0. Remember, sine 0 is 0, arc sine of 0 is then 0. So we're not going to get that term. F dash x, that's the one we're given in the formula book, so 1 over 1 minus x squared. And then f dash of 0 is just going to be 1 over the square root of 1. Hey, it's 1. Brilliant. So that one's okay. Now on to f double dash x, the second derivative. Okay, well, I can write this. I don't need to use the quotient rule. I can write it as 1 minus x squared. I forgot to square. 1 minus x squared to the power of minus a half. And I'll just use the chain rule. So I will get minus a half. Bring the, basically, remember, we differentiate. Probably done this many and many a time now, but differentiate the outside, leaving the inside the same. So minus a half, 1 minus x squared, and then lower the power to minus 3 over 2. And then times by the derivative of the inside, which is minus 2x. And that is going to give us x over, I would write it back as a fraction now, 1 minus x squared to the 3 over 2. And f double dash of 0 is 0. So that one's gone. Next up, it's going to be, remember the pattern continues, so it would be x cubed over 3 factorial f triple dash 0, and so on in that way. Right, let's work out f triple dash of x. For this, I will use the quotient rule. You could use a product rule, like leave it as a product, but no, let's use the quotient rule. U, v, remember it's u dash v minus u v dash over v squared. U dash is 1. V dash, looking that nice is it, it's going to be 3 over 2, 1 minus x squared to the half. And that's me dealing with the outside again, times by the derivative of the inside, minus 2x. So I will get 1 times v, so 1 minus x squared to the 3 over 2 on top, then minus u, which is x, times this. So actually it's going to become plus 2x squared. Oh, I forgot there's a 3 over 2 in there as well. This is going to become a 3. Right, I've done quite a lot in one go there, but we are doing this multiplied by x. And so I get minus 2 times 3 over 2 gives me minus 3. I've got x times x, that's where the x squared comes from, so minus 3x squared, then multiplied by this. But remember, because I'm minusing it, it becomes a plus. And all over 1 minus x squared to the 3. F triple dash 0. Well, the good news is that loads of this cancels out. This term is just going to cancel out when I put 0 in, but I'm going to get 1 from here, and I'm going to get 1 from here. Actually, I just get 1 again. So that bit is sorted, and we've got ourselves, remember, it was the first two non-zero terms. We've got them. So therefore, arc sine x is approximately, or you could just say it's equal to, it's going to be, remember there was no f dash 0, so it's going to be x, because it's x times f dash 0, and f dash 0 is 1. Maybe I'll write it in full. Plus x cubed over 3 factorial times f triple dash 0, which was 1. That is going to give x plus 1 over 6 x cubed. Okay. All right, it's always a good day when you're finding a new method to estimate pi, and we can use our Maclaurin expansion here to do such a thing. So subbing in x equals a half, we're going to get the arc sine of a half is approximately equal to a half plus 1 over 6 times a half cubed. But the thing is, arc sine of a half is actually pi over 6. Sine of 30 or sine pi over 6 is a half. Arc sine of a half is pi over 6. Of course, you got your calculator to check it as well. But if you know your exact values of trig, it's just quite nice to do it without your calculator. So pi over 6 is going to be approximately a half plus 1/6 times 1 over 8. That's 1 over 48. And that ends up being 24 over 48 plus 1 over 48, 25 over 48. And therefore pi times through by 6 is going to be roughly 25 over 8. And that is our estimation for pi. Of course, it's only looking at the first few terms of the expansion. It's not going to be particularly accurate, but it's not too bad. It's 3.125. Okay, it's correct to 1 decimal place. Anyway, it's still pretty cool that we can use the Maclaurin series to get it. And if we wanted more accuracy, of course, we could include even more terms. And maybe you want to look into that, or maybe you want to move on with this paper. Well done.